Galileo Galilei was an Italian astronomer who built telescopes, drew maps of the moon, discovered Jupiter's moons, spent his life under house arrest by the Inquisition, and threw things off the top of the Leaning Tower of Pisa. He was some guy. Before Galileo, it was generally known that if you throw something off a tall building, it'll speed up, right? But he decided to do some measurements. He had a ball dropped off the side of the Leaning Tower of Pisa, and with his telescope and a pendulum to measure time intervals, he found the speed of the ball at regular stages of the flight. He could then draw a speed-time graph, just like we've done, and from that, find their acceleration. As I said, he was some guy. He did this with a bunch of different ball types and found that the acceleration of these balls when dropped was always 9.8 meters per second each second. If that number sounds familiar, then well done. That number is also the gravity field strength of Earth. If you use something very aerodynamic, like Galileo's small balls, then effectively the only force acting is gravity. So it kind of makes sense that the acceleration of the balls is decided by Earth's gravity field strength. This acceleration value is known as the acceleration due to gravity. For his next trick, Galileo threw some very unaerodynamic things, like feathers, off the top of the tower. Unsurprisingly, they took a lot longer to fall, and people could have guessed this long before Galileo. But Galileo decided to actually see what was going on. What he found was that for something with a lot of air resistance force, the speed doesn't keep going up at all. You very quickly reach a speed limit that the object can't get beyond. What was happening? What was going on was that the air resistance force upwards had gone up and was now balancing out the weight force downwards. And balanced forces mean the object moves at constant speed. That's Newton's first law, remember? So because forces have become balanced, further acceleration is impossible. This speed limit, because of balanced forces, is the terminal velocity of an object. The terminal velocity can be read off the speed-time graph. It's the flat part of the graph showing the steady speed, and you can read that steady speed number from the up-axis. But back to his small, aerodynamic balls, Galileo now started dropping some, just like before, but then also chucking some forwards. And he found that it didn't matter whether a ball was dropped or thrown out forwards. So long as it was aerodynamic, the vertical downwards acceleration on each ball was still 9.8 meters per second each second. Yes, of course, the ball booted forward would cover some forwards distance too. But just thinking vertically, both balls had the same acceleration of 9.8 meters per second each second downwards, so each hit the ground at the same time, whether thrown out or dropped. This actually happens, kids. So go watch the Mythbusters episode where they do this with 2 bullets rather than balls, and you'll see that the bullets hit the ground at exactly the same moment. Galileo then realized that if you know that acceleration, a, is 9.8 meters per second each second, and you know that starting vertical speed, u, is 0, then you can use our favorite acceleration formula to calculate the final vertical speed v of each ball, just before it hits the deck. This applies to both balls, not just the ball dropped. The ball booted forward does have horizontal speed, sure, but it doesn't start with any vertical speed. The ball is booted purely horizontally. Yes, if it was kicked upwards or fired downwards, the ball would have some starting vertical speed. But it wasn't. The ball was kicked out purely horizontally. So the kicked out ball also has u equaling 0, also has AE equaling 9.8, and so you can also use our favorite acceleration formula to find its final vertical speed too. As the final step in his ball play, Galileo realized that for that ball booted out horizontally, the horizontal distance covered at any moment in time could be found by using the formula distance equals speed times time, whilst vertically, the ball is speeding up, is accelerating. Horizontally, however, there is just a nice steady, constant speed. So if a question asks you to do a vertical calculation, you know you're going to use the acceleration formula, AE equals v minus u over t. But if the question asks about anything horizontal, you know you'll just be using d equals v times t. Of course, if the object is not being booted out forwards, but is just being dropped, then there won't be anything horizontal to calculate at all. The only thing the question will be able to ask about will be the vertical motion, for which you'll use the acceleration formula, AE equals v minus u over t. Just one final worked example to do, then we've done motion, like completely. Stay with me, troops. Bring it. So a ball is thrown horizontally with a forwards velocity of 1.4 meters per second from the top of a cliff. It takes 0.9 seconds to reach the ground. Calculate. AE, the horizontal distance from the base of the cliff that the ball lands. B, the ball's final vertical velocity just before it hits the ground. And there's a cute picture. Well, horizontally, we know the ball will be traveling at steady speed. So horizontally, we are only ever going to be using the d equals v times t formula. Here, we have speed, we have time, and we are trying to find distance d. So we just put those numbers into the formula, and out comes the answer. Vertically, we know that the only formula we are ever going to use is the acceleration formula. And we know that with these questions, the acceleration value is always going to be 9.8, and the starting speed, u, is always going to be 0. So we can substitute those numbers in straight away. That then only leaves the time t value to put in. Work the maths, and give units to that final answer. Can you follow what we've done? As promised, this is the end of motion. But please go back and re-watch these videos. There's a lot of stuff to get your head around. You can absolutely do it. The mists will clear a little more every time you watch, and before you know it, this will all start to seem kind of doable. Keep the faith, go get a coffee, and watch again.